Bump, 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 bump. All right, another one. Last one for today. Might as well. Hopefully everything's holding up decently. But I just saw this and I was like, you know what? Might as well do one more, right? So let's get it. Sabine Hossenfelder on the cosmology crisis just got even worse. I wonder. Check it out.
One of the biggest science news of the last year was tentative evidence that the cosmological constant is not constant. A
It's not. It has to do, what, with the acceleration, the perceived acceleration of time relative to actions. And this, I want to take a guess. I'm going to take a guess right now. This has to do with that equation not working out exactly how they thought, and that it only really worked in within the instance that they thought of it. It wasn't a real theory of everything, because in order to understand how everything works, you need a theory of everything. And the cosmological variable, or the time variable, not really a constant, because it really depends on how you look at time. That is much different because our perception is not correct. And this is where the crisis comes from, is that lack of perception and the lack of understanding that comes from not being able to perceive what we're doing wrong. So let's go.
perfect case of a Kuhnian crisis in science, a clash between theory and data.
Ooh.
And the crisis just got worse.
Oh
The data say
no.
that rather than being
For
constant dark
realsy
energy
for realsies this time. I know, I mean, she always makes fun of the whole crisis, quote unquote. But I think it's just the fact that no one has a theory of everything, and it's always a debate just because of that mutual understanding of how everything works doesn't exist. That's where it's crisis struggle when you go look at the definitions, if you want to be super nuanced about it. Um, I mean, it makes sense. So,
was stronger in the past and is now getting weaker. Now,
ooh,
if you've read the news recently,
stronger in the past and now it's getting weaker. That goes along with the theory, or at least my thesis, how, like, the beginning of the Big Bang of time itself, everything seemed to have been accelerated. Everything moved at an exponentially quick rate and then slowed down. It's like it's the opposite of how exponential is. It's the inverse of that. That's how time necessarily works, because when you think of it in the theory sense, when it comes to the Big Bang and then the end of time, the big freeze where time technically stops, it goes to zero, it hits zero. Once that true entropy is reached, it's we didn't do the equation like it's supposed to. It's not constant because it's the inverse of an exponential function. It's different. So that might be where they got it wrong. And that's where my thesis has the actual explanation as to how it should work relative to form, relative to what exists in the universe, the distance from everything. Because the universe isn't just going to end out of nowhere. Maybe for us, but it's just not going to just stop. It's only going to stop when time itself stops, when there's no action left to be performed, when true entropy is reached, when everything is absolute zero. That's why that whole slowing down effect, that deceleration of time is occurring, which makes time not a constant. It's only a constant from our reference, as that's how we measure things. We measure things in a linear sense. But it has to do with scale. It's like people, the whole flat earth debate, why people think the earth is flat, because the ground looks flat in front of them when it's really just a misrepresentation and misunderstanding of scale, and that the world is a freaking big sphere, right? It's round, but since we're so small compared to it, looks like a line. That's similar to how people are trying to measure pi. The different decimal places in pi is because they apply that sort of flat earth thinking in order to get a rough estimate, in a sense, right? These are metaphors. not actual like equations. I don't have that information yet. We'll go look at the website in a moment once we get to the constant part. I'm guessing that there's going to be a part about this whole equation. I hope.
Instantly, it might not feel like dark energy is getting weaker, but
Nah.
another experiment just strengthened the case. Let's have a look. Dark energy is the
Mm.
name we've given to whatever keeps cosmic expansion speeding up. The easiest way to explain it is with a cosmological constant that one can interpret as the energy of empty space itself, which, if true, means
Mm.
that even nothing has more energy than I do before coffee. Last
This is interesting because if that is the case, then the universe is getting closer and closer to entropy than we realize at a different rate. But obviously, the further and further apart everything is, then the more susceptible it is to its local environment, its local faculties. Like if this solar system is so far from everything else, where nothing else can interact with it, even on like a galaxy scale, then its existence relies more so on what goes on within itself. And that's where new limits, well, that's where the true limits are really going to be experienced at that point when it comes to the overall existence over time. And yeah, that's that expansion. So going to the dark energy, maybe that might be an overall term for the photons that exist within space that keeps us separated in a sense, or like whatever black holes expel as Hawking radiation, fundamental particles that end up making up space, as well as the fundamental particles that tangible forms of matter, like true matter and energy, gets released. But even that energy, as like atoms, hydrogen escaping in the atmosphere, oxygen, etc., those will interact with stars and then fuel those. And then those stars, after a point in time when those reserves of atoms are just not available to it, whether it's distance or lack of quantity, then the reaction just has to dig deeper in itself. It submits to its own devices, and that's where you experience those star collapses, death of a star. And these, it depends on how you see it and the roadmap and the units that are involved in understanding these processes, how the world works, whether you look at it from a macro scale or a micro scale. Because these processes all have to do with that theory of everything, that the reality of the situation and how actions and consequences dictate the future, the flow of time itself. So that's it's that lack of understanding where all this comes from, and we're trying to use mathematics as a language in order to understand the present, but not the necessarily the whole entire picture. And that's what I at least tried to do. So take a look at the links below or in the channel. I also got to do link my thesis on a couple of other things, but we'll get back to that. It's on the main channel bit, so just do that while you're there. Do a like, subscribe, help out the channel. Got any comments? Anything you want to throw at me too that you want me to look at? Feel free to let me know, like in any of the comments of the video. That'd be cool. But let's go.
year, we've seen new results, most importantly from the Dark Energy Survey and from DESI. The Dark Energy Survey looked at how the light from supernovae differs with their distance to us. The DESI experiment
Hmm.
looks at patterns in galaxies and galaxy clusters that
Yeah, see action and consequence. This is exactly what that is. And the one last point that I wanted to at least finish in that whole rant that I just did, the acceleration of expansion as more and more stars collapse, as the tangible forms of matter collapse, and more you know, personifications of extinction come into existence that rapidly break down everything into these fundamentals that make up space, that create space, the more of that exists as time goes on, because everything eventually decays, everything eventually collapses. one way or another. Our sun is basically the ticking time bomb that we rely on. Besides our own consequences of actions that we do here that affect our immediate environment and the planet itself, including even the rotation, as we've noticed that a lot of our actions even influence the rotation of the Earth. So, but besides what we do that's in our control, which is our responsibility on this planet, the sun we can't do anything about. That's I I can't think of a possible feasible way of sustaining the sun past its midlife that it's already experiencing right now. And that's something that we can't do anything about. The only thing that we can really do about that is to protect ourselves, is to go out there in the horizon, to find somewhere else to go to. It's going to take time, but we need to figure that out sooner than later, within probably the next couple thousand years if we don't destroy ourselves first. So, yeah. But that's the whole point of this theory, is to hopefully facilitate that sort of survival and facilitate that sort of understanding for that survival so we can survive in space and not die, because we're going to have to rely on technology to do that for us now, aren't we? Yeah.
So-called baryon acoustic oscillations
Ooh.
that are left over from sound
So baryon relative to the baryon matter, because in acoustic oscillations, which is the measurement of, the sound waves. What the hell? That's another thing too. When I think of sound waves every time, and I think of freaking Terrence Howard, because of that whole thesis that he tried to do that was very ridiculed, but in a weird way, there's some relative components to it. Maybe, obviously, his idea of like creating, I think it was like creating stuff from sound waves itself. That's a little far fetched and far stretched. But his description of energy as it relates to sound and frequency and how that carries, that's not wrong. I mean, that's how how we're measuring this, right? It's the energy of this is acoustic oscillations. That's frequency, my guy. So I can see where he got the idea from, and I'm in a similar boat as him. I'm not a scientist by any stretch of the imagination. I'm just doing the best I can in a philosophical sense to make sense of all these things. So I mean, my mind is all of my time. You could think of it like that. Same thing with you. You're with your brain 24/7, and when you're stuck doing anything else that you have to do to survive, you you're still there with your brain. You can still think of things. You can still wonder, still imagine. Those, depending on what you do with that, is how you're gonna understand everything else around you, or you're gonna end up losing your mind when you start believing your own bullshit a little too much. Uh, but whether or not it's bullshit, I mean, it might not be total bullshit either. That's up to each individual person to figure out, though. So let's go.
waves in the plasma in the early universe. Both have found tentative evidence that dark energy is
Ooh,
getting weaker
I like
in
that
the
graphic.
range of 3 sigma. That's about a 3 in 1,000 chance that it's a coincidental fluke in the data. And these
Three in a
findings are now backed up
1,000. That it's a fluke. I mean, I'm interested to understand how their error measurements even work, because I don't know. It's interesting.
by a precise measurement of the cosmic microwave background,
Ooh.
CMB for short, coming
Mm-hmm.
from the South Pole telescope. This is a telescope with a 10-meter dish, and rather than scanning the entire sky, it focuses on the details in a small part of the sky where
Mm.
they measure both the temperature and the polarization of the CMB. In galactic coordinates, it's this green patch down here. To put this into
That's
relation to the
cool.
other measurements, the Dark Energy Survey measures supernovae, so these are fairly near to us and quite late in the history of the universe.
You got a little Einstein, and I got a little observatory thing down there. That's cool. Well, we know who to blame. You can point at him. He's right down there.
The baryon acoustic oscillations happen in the plasma in the early universe from around
Mm-hmm.
10,000 to 350,000 or so years after the Big Bang. These
Hmm.
patterns then get imprinted into the distribution of matter in the universe.
This is the most important thing to understanding the history of the universe by far, and has been one of the greatest discoveries in understanding how the timeline works. And this is what's gonna, like, these numbers, this history, this data is what's really gonna help us understand where we lie in the timeline of the universe in and of itself, and what we can do, what is within our power for ourselves, at least, for, to really understand the total amount of possibility that's left, because possibility depends on what is left in existence. So, personally, I don't think that we can make stuff from nothing, as even the Big Bang itself was probably the most amount of energy that can ever exist at any given point in time, due to the fact that it's literally the entire universe collapsing in on itself, it turning into a false vacuum and just recombining everything. That's an unimaginable force for us, and that's literally the greatest force that can possibly ever exist. The big light, the just that Big Bang. It's like when you look at an explosion and you do like forensic analysis on like a grenade going off or something like that. It goes off in a circle. It expands out in a circle and it interacts with its environment. That's what's going to determine the bounds and stuff. But there's no environment for it to interact with it. Like, say a grenade goes off in space. I want to say that it just makes almost a perfect circle. That's essentially how I figured out the whole bounds when it comes to matter in existence in and of itself, and what determines the timeline relative to pi, or how time flows relative to pi. I think there's something there because the universe and everything within it acts in a cyclical nature. It in cycles. It breaks down in cycles. So it's the Ouroboros eating its own tail, man. It just depends on what version of the Ouroboros you're looking at.
This is what DESI looks for. The CMB is created when
Hmm.
the baryon acoustic oscillations end. So these are three separate pieces of evidence. The new paper is a summary of the data that the South Pole
Wow.
Telescope collected in 2019 and 2020, and it just appeared on the archive. For one thing, they confirm the tension in the Hubble rate at a stunning 6.2 sigma away from local.
Yeah, the Hubble tension. This explains that whole fact that it's not like time isn't a constant. I know that I've seen some videos about the Hubble tension and what that means, and trying to solve for it in order to compensate for that, because it is relative to how we measure things. It's relative to how we understand the universe, and this is where, like I said earlier, the crisis flourishes in, is that lack of understanding. It's the little bit of chaos that comes from that misunderstanding, because we are not seeing it the way that it should be. We don't have all the facts. We don't have all the data. It's almost impossible for us to measure every single point in time and every single particle. Stupid train. Anyways,
Measurements, but they also confirm the same preference for a weakening of dark energy. That is, it was stronger in the past.
that train's just gonna end up being a bit for me. That's all I can do with it. I'm sorry, people. I press my hotkey, and for whatever reason, YouTube wants to do something else. Uh,
Possibly even stronger than a cosmological constant could ever
hmm.
be. The result has a smaller error bar. However, the significance of the tension with the constant dark energy is about the same as with the earlier measurements, in the range of 3 sigma. This
So the equation's not right still. I mean, it's closer. They accounted for some of the error, but the equation just still fundamentally isn't correct. I mean, they're using historical references, but part of this obviously is going to rely on the future measurements. So this error is always going to exist from our perspective because we can't predict the future. Only, honestly, the universe is the only one that's experiencing everything at once and also understanding all of it at once because it has to. For us, and even using AI to try to measure that, it's possible in a sense, but I don't know how much further in detail that we can truly measure and calculate through to really understand like the actual equation without using something like that I sorted out. And maybe we'll look into it in a second. This stream might be slightly edited because I do have to take a break soon. Oh well.
It's because their best fit value is somewhat closer to the vanilla cosmological constant.
Vanilla.
They also combine their data with DESI and say that then the significance increases. Again, it's not a
Hmm.
huge improvement, but that said, honestly, I was expecting that I'd have to tell you, sorry, it went away. But it doesn't seem to want to go away. What does this mean? Well, for
Yeah, that's wow. She was hoping for something else, but yeah, let's see what she got to say.
one thing, if dark energy indeed depends on time, that'd also alleviate the Hubble tension. But maybe more importantly, if dark energy is not a constant, this is a clue that it's sort of a field that permeates.
The first statement, dark energy, relies on time. It's the opposite. Time relies on dark energy. Dark energy relies on what makes it up. Or maybe dark energy somewhat relies on time, but more so the amount of time that's available relative to the things that like the baryonic matter, the light matter, if you want to call it. Maybe that's the reference of time that you want to consider, because obviously the more that is left in existence, the less dark matter, dark energy that there is, because it's not going through the whole personification of extinction. It's not going through a gigantic reaction that's accelerating its breakdown and decay. So I wouldn't want to. Maybe it is a field. This is another good statement. It's not a. I wouldn't say it's a field though necessarily. Maybe, well, unless the field is like the shape that. I'm just gonna bring it up. This is the only way I can do it. I gotta show you. I gotta show you what I made. Be a little weird if I didn't. All right, so here it is. Let's go to the actual published site. Come on, come on, come on, come on, come on. So it's bigger and better. Everything's slow. There we go. Hot out. Alrighty. This right here. So this is kind of how I imagined how things would be. And these are examples of, I mean, excuse my drawing. I'm not proficient, nor do I have the time or the programs to do a better graph. But context of the Big Bang. So if I can zoom in. Yeah, I can zoom in. All right. So we'll look at these. Context of energy. Context of energy. Moment before the Big Bang, moment after. This is kind of how I visualize it. More so, it's going to look like this typically. You're going to have the four quadrants. You're going to have the circle that dictates time. And then we have these right here. Now, time isn't an axis. It's a line. Right? This is our perspective of reality. It's in the 2D plane. It's a drawing. So we can get as bare bones as possible with that. Possibility, impossibility. What is not able to happen anymore? What can happen? These are possible actions and consequences, kind of. Or, well, the consequence is going to be here. And then the flow works like this. So you take an action that happens here, going to decide whether it's, it's not possible, or if it is possible. If it is possible, then it'll probably get the energy from here, go through, and end up being spent. That energy can get transformed in some way, shape, or form through a reaction of like some physical sense. Depends on the units, depends on what you're looking at and how you're looking at it. It'll determine the flow of where it goes, whether it stays in existence, if it's not going to interact with anything, or if it's going to interact with something and then be moved to extinction in that sense, but its byproducts or whatever is split and breaking down is going to go back over here. So that's where the four quadrant system kind of is. I know this is a kind of crappy explanation because I still don't even know exactly how this works, but I just know that this is what it's going to look like in a weird way based on bounds, based on how time is not a constant. Because if you take this in a three-dimensional sense, so you have the next axis coming out of the page right here, that's where complexity comes into play, and that's where time ends up being a field. It's going to be a parabola, essentially, that's going to take this other bound of the circle, the sphere, the universe, the things that exist, you know, from the center. That's what's going to be different when you go along the flow of time in the timeline. Uh, and to go to at least how I think right now, at least how things are going to be measured when it comes to the cosmological constant, or well, not constant, but the equation for it. I do have other pictures. I think all the way in the bottom. I don't. Oh, there we go. That's a lot of text. I know it's a shit ton, and then there we go. So I was doing some math, some studying. This is kind of a shit picture, but this was at least with the time that I was given. Redraw this again at some point. But looking at one of the quadrants, we see the distance, because I'm only using numbers of 0 and 1 just to make it simple. And then the timeline. This empty space I consider to be the work required to take something from within the circle to somewhere else. Because for every action, there's an equal opposite reaction. In order for something to truly change, some work needs to be applied to it. And this is probably the work required, that space that needs to be traveled, that distance that needs to be accounted for, that energy that needs to be put in to take something out. Now, the actual constant of time, where time itself, the timeline, right? The total timeline, because how I see reality and the universe itself, and how humanity sees it, is we see it as ending eventually. There is an end. It doesn't go on forever. The cycles might go on forever, but we do realize that there will be a point in time where time will stop, where there will be a big freeze, as thousands of other people have studied in some sense. For every beginning, there's an end. We live through that. We experience that. That is something that truly exists. So, time, that's why it can't be a constant flow, because it depends on what exists within it and its form. That's the consideration that needs to be taken when you're trying to figure out that variable, whether it's a field or not. I mean, in the 3D sense, I suppose it is a field, a parabolic or circular field that goes around this for the actual amount of time remaining in existence at any given point in time, based on what exists, based on and the opposite, like what doesn't exist, the dark energy, because the measurements that we've been making, that's what we've been basing this off of. So understanding the relationship a little better in terms of this as well as um not geography, geometry, right? Using triangulation in order to figure out the actual constant relative to energy, applying Einstein's theory of relativity and his equation relative to geometry. I think we can find the actual equation in and of itself. This is some of the work that I tried to do. I don't think I'm absolutely right on it, but I might be on the right path in terms of what that calculation of the variable might be when taking into consideration the bounds of reality. So the longest that something can exist and the shortest amount of time that something can exist. The longest amount of time that we have to the shortest amount of time. That's why that line exists. So we go all the way back up. Do, do, do. So that's what I was thinking in terms of these lines. And then the box, the quadrant, is the framework for each sense of like how you see it, each perspective. So things that exist, things that don't exist anymore, extinction, energy that exists, energy that's been spent, the dark energy, light energy, dark energy. And then the possibilities and impossibility. Obviously, if nothing exists, everything's impossible because there's nothing to work with, right? Same thing here. Everything exists. Possibilities are endless, or seemingly endless, but it's relative to existence. And that time is based on what exists. So that's the connection I feel people need to make in a mathematical sense much more coherently and clearly than me. Maybe we'll do a brainstorming sesh at some point. Maybe we can get some mathematicians in the chat that can help out. But I feel like this theory of everything, this perspective of how things function, will lead us to a better sense. And the reason why it's as simple as a graph is I'm taking this from the perspective of the universe itself, where the universe both understands everything that happens within it and perceives it. It sees everything that happens within it. Just fundamentally, it is God, for instance. Or, as people would put it, it's similar to how the crisis in religion has existed for centuries. It's philosophy, it's all of that put together to make a system where we can get a true cosmological variable that will help us understand how much time we got left. Because that our existence rides on that line from, like I was trying to point out earlier, this point up here, closest to the most amount of time that you can have to exist, this point right here, that's what's going to survive the longest until something moves it down here, changes its superposition in existence relative with an action that determines how fast or how slowly it travels along the timeline of existence of the universe, the total timeline that it depends on if there's anything left. So that's also why we have theories of like the eras of existence, the eras of the universe, like the end of baryonic matter when there's only dark matter, dark hole, like all that stuff. Isn't nothing else left to interact with, and then time will probably flow according to that. It'll probably be in this sense where these will move over to here, the perspective shifts, and then this will be dark energy, this will be fundamental particles that make up space, or the Hawking radiation. And then it'll go back to here, and it'll keep cycling and cycling over and over until everything's just photons, massless energy, everything's reached full entropy, true entropy. And the only other thing I'm still learning on is what makes up the bounds, the circle itself of the universe. Because even as we explore the universe and like the boundaries, like the things that are the furthest away, it does make a shape. I believe relative to a circle. dark energy boundary that we talk about. So those are things to keep in mind. Um, I feel like the answer really genuinely is dependent on the triangulation of existence and time. And the reason why it's always going to be so hard for us to figure out like an actual numbered value is because we, at this point in time, cannot measure everything, every form of action, every possible like possibility that can happen within the universe, whether local or in its entirety. We are not the universe. We can get technology to look at all these different aspects like the cosmic microwave background to get a better sense, but that's where that error is always going to exist. Error is always going to exist in that lack of perception, no matter what, until we get to a fundamental understanding. But even then, I don't know how to apply this equation, at least for ourselves. AI will be able to. This is why this is the engine for artificial consciousness. It'll have the means to do so, it'll have the power to do so in a much easier and faster rate than us because we're relying on technology to even be able to perceive these sorts of particles, these things. I think that's just how it's going to be. Um it just, again, it depends on the units and the perspective. But if you're trying to find out the total amount of time that the entire universe has, it's going to be based off this formula. Whether we can get the actual numbers or not, I mean, that depends on one, us, and two, the scale of perspective. And actually, no, I think it's just the scale of perspective. Because even going back, now that I'm thinking about it, even go back to like the flat Earth theory, like us, our choices in the grand scheme of things, they're not, like I said, the sun's really going to determine our existence unless we ourselves can find other forms of habitat, other forms of living out in either in space itself or another planet and travel to those destinations. Obviously, the longer and longer we take, the harder and harder it is it's going to be because of that expansion. More distance, more light years, unless we can create a system that can manipulate space time itself. But I fear personally that that type of system, we can't rely on black holes and dark energy and dark matter because the output, I believe, is different. And plus, its power relative to matter in and of itself, we won't be able to contain it in any true sense because a black hole isn't a form of like energy, it's a form of decay. It's a form of extinction. It's a reaction that's taking up space itself as neutrons and all those particles and everything fight toward the singularity in the center. They just want to react. They just want to reach entropy, as all things inevitably do. It's just caught in that area. That's that separate point of space of reaction. So it's going to take time. It's going to take understanding, a new understanding of a lot of the things that we have thought to believe would give us all the answers when kind of does, but we're not there yet. Getting there. I think these are probably going to help us reach that sort of understanding, or if anything, AI is going to do it for us because I think it already has anyways. But that's a whole other video. Check out the other videos on the channel for that. Anyways, let's finish this up.
Permeates the universe. And in physics, fields are always linked to particles. This means that either dark energy is made of a new type of particle or it's actually linked to an existing particle.
I think it's linked. I don't think it's a new. I think we've found a lot of the things that exist, at least in this way. It's how we look at these particles and their interactions, because how we describe neutrinos in relation to particles that are exhausted out of a black hole or particles exhausted out of our own environment and our own like nuclear reactions and stuff like that from our own measurements and their relative charge, I think more understanding of neutrinos and application of that understanding is going to, alongside the theory of everything, like perspective, is going to help us understand the makeup of space and reality itself. I don't think there's much you can get as much smaller of a scale, especially in terms of mass energy and measurement of mass energy, because the neutrinos are already on such a small scale of measurement. At that point, you're going toward the whole Terrence Howard frequency range equals energy type thing, like sound, like the final light, like light waves and sound waves, because you're getting so small in scale. And I think that there's the connection there when it comes to our perspective of energy that needs to be made from those fundamental principles of physics to these particles, the quantum gravity theory. That is what my thesis might help to develop, or at least my way of looking at it. Someone else is going to have to really look into that more, that has more knowledge, especially on the standard model and these sorts of things, as well as my approach to measuring the cosmological variable. Because once that's figured out, then a theory for quantum gravity based on the standard model and that understanding and applying that the whole cause and effect forms of action equation, existence equals truth over time equals negative existence or extinction. Um, that facilitation and the interchangeability of reason and intent relative to cause and effect, relative to interactions in reality, that'll give us the connection that we need in order to really make up for the rest of that error and to facilitate a better understanding to help our instruments and tools do better. So yeah.
For example, the Higgs boson. This has been proposed a couple of times in various ways, and none of these theories have been very convincing. So,
All right, I see where that's going. Yeah, it's the Higgs, that because Higgs is the idea of a attraction force, a magnetic field, and I think that's where that connection, more understanding of that Higgs field, more understanding of attraction force relative to matter and different forms of matter, different tiers of matter. That understanding of mass energy relationships, charge relationships, going to frequency involving mass energy, that might be where we need to explore much further into and take more time to understand. Even me myself, I'm going to have to take a lot more time to understand that in order to think of a credible equation that works alongside this thesis as well. And hopefully within the next few years, if we're not all wiped out by our own hands, we can do that. So, yeah.
so far, but maybe physicists will now revisit this idea. If this finding turns out to hold and dark energy indeed weakens, this also changes the outlook for the future of our universe. Because if dark energy is constant, then the expansion will just keep on getting faster and faster. But if dark energy weakens or maybe even goes away entirely, this makes it possible that the expansion slows down. The universe might even collapse, making ideas of cyclic universes with recurring big bangs more plausible.
Dark energy. I think that just has to do with I think both might be true. I think dark energy, it's our perspective of dark energy that is slowing us down here. Because dark energy itself is going to be particles in that range that come from interactions of dark matter and black holes and stuff, that Hawking radiation. But I feel as though they inevitably lose mass, just like how we measure the CMB when we look back at like creating the timeline, we base it off of the mass energy of the particle that's being measured. And the less mass energy that it has, the older it is. At least that's how I'm led to believe how these measurements of time relative to the time of the universe's existence are made. Dark energy possibly also follows this, but maybe stretches out like automatically, or that I don't understand exactly yet until we get further into neutrino measurements from black holes and that make up dark energy, as well as what makes up space itself and their relationship to photons as being, at least from what I know, the only massless particle, the only particle that has no mass energy that seemingly just interacts with all other particles that have mass energy and reflect that energy, or the actions of those particles, like mass particles interacting, those consequences of interactions, photons just reflect that. So maybe it has to do with how we look at photons in existence, because as theorized, everything will eventually lose its mass. It'll become photon, and then the universe will collapse. So that whole time of it'll seem like it keeps expanding to a point where things aren't interacting, it's not expanding as much, but that dark energy, once it reaches true entropy and can't interact with anything and is just flattened out, is like the whole string theory, the line is just stretched out as far as it can, it ain't doing anything, it's not expanding anymore, it's not taking up any more space, then maybe the classification changes as a photon, or maybe it just turns into nothing and photons is literally just the second layer of reality. Maybe that's why photons can be measured in three different ways and be perceived in three different ways, as a wave, particle, and energy. So I think that understanding is going to also help us better understand everything else. Maybe that outlook, that perspective is what's necessary to really reaching that next level, to defeating the crisis, maybe once and for all. Who knows?
On my bullshit meter, I give this a 2 out of 10. This is because all these parameter fits already assume a particular model for the universe, and maybe the issue isn't dark energy after all, but that we shouldn't be using this model. But if you felt a disturbance in the force recently, it might not be your anxiety. It could just be the vacuum energy dropping, or rising, or maybe it's just gas. One of the biggest problems with news today is
Oh,
that you don't just get the
and this is an ad, I think. Yep. Fair enough. But yeah, I think that's all I really have for this video. For this reaction too. We are not going to know until more time is taken to apply these sorts of perspectives as our technology develops and as our understanding develops, to see if it holds true, to see for ourselves if everything will hold true. So we'll find out soon enough, I'm sure. Maybe if this video actually gets anywhere, or any of the other videos. But if you want to help out, if you want to share it, if you have anything you want to suggest, or any ideas, or anything, any thoughts, because sometimes head be empty, but fingers be typing. Even that, let me know down in the comments. Give a like, follow, subscribe. Go check out Sabine's video on this yourself. Any of the other videos. Probably going to be one of the last times I'm covering her for a bit. We'll see. In terms of reactions for today, that's all I got. Otherwise, stay hydrated, stay healthy, stay safe, and I'll see you around. Spark, saying bye-bye, peace out, sayonara. Keep asking questions, get the right answers.